Hi there, welcome to this Brooks Audio tutorial on acoustic treatment. I have been thinking for some time that I probably should be able to improve the bass in my studio. It was a bit lumpy. I couldn't really get a clear impression of what was happening in the low end from my mix position, and I wanted to improve things. So I want to talk you through in this video how I measured the room using a piece of software called RME Wizard, how I then treated the room and made my bass traps in the corners, and then finally measuring the room again and looking at the results. And I really hope that you'll get something out of this, which means that you can achieve something as good in your studio. Let's have a look at it. Let's go. Okay, so this is the software that I recommend that we use for this process. RME Wizard is rmeqwizard.com. This software is available for both PC and Mac. You'll be happy to hear. So what does it look like? Well, if we go across to that, this is the home screen within the software. The first thing that we need to do is set up our preferences. So in the top right corner, we can open that up and we can see here the sound card that we have. So my Fireface 802 has come up as the output device. I would recommend using the sample rate that the sound card is set to. That just keeps things nice and tidy. So find out from your hardware settings what's your sample rate. It'll likely either be 44.1 or 48 kilohertz. I tend to run projects at 48 because then video it becomes a bit smoother if everything's at 48. If you're wanting to do things for sync to video and that sort of thing, computer games and things, then 48 kilohertz tends to be the one to use. Output device here, we're going to use our the default routing, I think, or we use the Fireface 802, and we can set the output hardware outputs that correspond to this name. So I want to measure left and right. I'm going to measure my whole system, and I'm going to measure what the result is at my listening position. So through left and right, which also in my system will also route to the sub as well, which is good, which is what I want. I want to measure the whole system, and then the input will be from the Fireface 802, and it will be input 9, which in my case it corresponds to the microphone input on the front panel of the device. On yours it could be 1 and 2, or if you've got a larger sound card, it could be something that you need to find out. We're not worried about the timing reference output and input, the loopback input. This is for if you're doing timing critical things like measuring a main loudspeaker and a sub separately and then trying to use delay to time align them. You need to know absolutely critically that the latency of the sound card is incorporated or is actually ignored from the timing measurement. In our instance, this reference is not important in order to measure what we're going to do, which is a waterfall diagram, and that's this is not relevant. So we're not worried about loop back. Once we're happy that we've set our channel mapping, we can go down here and go to check levels, and I'm going to use my main speaker, which is my left and right, which actually incorporates my sub as well, to check levels. I'm going to turn down my output here because I just want to make sure that I'm receiving, sending and receiving into the software. And so there we go, that's sending out of the sound card, and I can see an input as well from my microphone there. Let's just check that again. So if we just have a look, this is the output and this is the input. Okay, that's good enough for now. So I can close this window and I'm going to go to the measurement window next, which is top left. Now, it's going to tell us that there hasn't been an SPL meter reading calibrated. So we're not worried about calibration either. We just, in this instance, we don't need to know the exact SPL precisely, but there's a way that we can do this in a very cheap and cheerful way. We're going to continue anyway. Here we've got our measurement window which pops up. We've already got our sound card settings here. We get to choose at this point where we want to start and end the measurement. So i.e. when we take a sweep, which is going to be a sinusoidal sweep, it's going to go in this case from 0 all the way up to 10 kilohertz. If you want to go higher, you can. In this case, I'm really focusing mostly on the 0 to 200 hertz, but I'm going to take up to 10k anyway. There's no harm in having that in the measurements. Yeah, I'm just going to do one sweep and it tells me the total time that's going to take. Now, we've already set up the sound card, so we're happy with that. The next thing to do is to check levels. And how do we do this? Well, I've got a screenshot here from a very inexpensive, in fact, it's free SPL meter, which you can get for your phone. This one's for iOS, but you'll be able to find something equivalent if you're Android. And what I'm going to do is, as per this photo, I'm going to hold it next to the microphone position, measure 75 dB coming back into the software, and that's going to mean that if I take a measurement before, then I move the microphone and then I bring it back again. Once I've installed my treatment, I'll be able to take a measurement not only from the same position, but also at the same level, which is really important. That's the most important reason for doing this. Okay, so once you're happy with this, these levels that you've checked, then you can start measuring. And these are once you hit the start measuring button and your mic's in position, you'll hear something like this. You hear a sweep. Now I'm going to open up the measurements that I took the other day and just show you my results. You should see. So this is my this is with no rolls in my room. So this is with the room as it was. I'm going to show you a picture. This is how the room was pre any treatment coming in. So it's recommended that you take a measurement at this point, so that you've got something to reference to before you've even brought the rolls of fiberglass into the room. And if I go to, I can see here a phase trace. If I go to the waterfall diagram, which is the one that I'm interested in, and generate a waterfall from this data, here we can see the region from 10 hertz to 200 hertz, and here we can see the frequency response. So this line at the back, so the y-axis is the SPL, which we're not worried about because this is not an actual SPL. This is just a relative SPL. It doesn't really matter because we're looking at differences rather than absolute values in this, which is important to remember. The x-axis here represents frequency, and then the z-axis represents time. And I've actually set mine up using the controls window here. I've increased the time range here, so I turned that up. I think it defaults to a lower value than that. So I think if you click on the controls panel at the top right, you can increase that to 1000 milliseconds, so 1 second, and that helps you with longer time period, gives you a longer time period, and really helps you to understand where the ringing, effectively, the frequencies that sustain in your room are. So we can see here that there are quite a lot of frequencies that are sustained, and not necessarily the ones that are the biggest peaks in the frequency response. So initially, yes, here we have 28.6 hertz. Yes, we do have a peak, and yes, that does sustain over time. Here, so we can see that peak sustains. But for example, here we've actually got a dip in the frequency response of the system, and we have but we still have a sustaining note here, a sustaining frequency. So this is an interesting one. if you were, this is why there's a case in point why you can't just look at a momentary frequency response of the system, the speaker system, and expect to be able to ascertain where the modes or where the frequencies that are sustaining and ringing in your room are actually correlated, because you would imagine that's got nothing, there's no problem there. In fact, the only problem is that there's not enough of that frequency band. But actually, when you listen in the room, because of the sustained aspect of that frequency, you'll then find that there's actually a build up there. So your instantaneous frequency response is not telling you the whole story. And that also goes on to explain why you can't just adjust your frequency response using an EQ in order to fix these things, because that's a case in point. Just because you turn a frequency down doesn't mean it stops it ringing. Okay, so an EQ will not fix this. This is why we need acoustic treatment in the room in order to solve these problems. So bring in the rolls of insulation, and I first of all just put them in the room in a big block in the middle, and as per the photo there, and let's see what result that had on the measurements. So this is the next measurement with the rolls in the back of the room, and I'm going to generate a waterfall from that as well. And as you can see, just by putting those in the room, we've got a marked improvement in the amount of frequencies that are sustained in this room. I was actually slightly concerned that by putting them all together in a bale like that, they would actually have a better effect, and that once I put them into the corners of the room, that they wouldn't be quite so effective. But I did it anyway. So as you'll see from the before picture, I had some diffusers. They're called Auralex T-fusers on the walls, this is the second reason that I wanted to do this, was that I wanted to move my my panels, the wooden framed panels with the Hessian or burlap cover. I wanted to move those more into the reflection points, so they became more absorption for high frequencies at the reflection points on the walls. So they've moved forward and out of the way. That was the first job that I had to do. I've put the T-fusers up on the ceiling, which has helped with some of the flutter echo. I had a slight flutter echo between the floor and the flat part of the ceiling that wasn't treated. And the nice thing about those T-fusers is that they're breaking up that rather than absorbing it. So there's still some high frequency reverberation in the room. It's just it's not so pingy as it was before, and it's much more diffuse, which is a really good reason to use a diffuser like that. So they're in a better position. And then I just positioned the rolls into the corners of the room, and put the had to cut a small amount off of the second roll that went into each corner, so that they fitted into the corners of my room like as they are now, and then covered with some lovely green material that my wife gave me, and then I took some more measurements. So this is the result of the final measurement of the rolls in the corners, with a bit of tweaking of the sub as well. So a little bit of tweaking with the polarity of the sub and the position of the sub as well. And actually managed to get rid of some of that dip, or well, at least the dip has moved into a slightly different frequency here, but it's not something which is particularly noticeable in my monitoring. And actually I can probably now that I've fixed the fact that was ringing, that frequency, I can actually do some EQ to try and make that a little bit flatter and a little bit smoother, which is something which I probably will do on the system as the next step. But that's something now I've got a nice result in terms of a treatment, then that's something which I can do. So if we compare the no roll there, that's with no rolls in the room, as in no corner traps, and this is with the traps in the corners, and then we can just compare again with that was it when they were in the back of the room. and that's with them at the front. So that my worry that they would be more effective in the back of the room in a big bundle, I think, is unfounded. Actually, they are very effective in the corners. They're doing a really good job. And actually what I've done, I've rendered to, so when you take these measurements, when you take that sweep, Room EQ Wizard is doing that, is creating an impulse response, and that's what it uses to generate this data, this waterfall data. It's using FFT, fast Fourier transform, in order to create this information that you're looking at here. Now, a big advantage of that is that you can, of course, then export that impulse response, which I've done. Export the impulse response as a WAV file, and that then allows you to put that into a software and do a convolution process. So we can convolve the two results, and fundamentally what that means is you can listen to a bass from my mix position, a bass guitar part, which with no rolls, so the room as it was initially, and then the second example is with the rolls in the corners as they are now. So here we go. Great, so hopefully that difference is noticeable. Probably better if you're listening to that on headphones, I'm sure. Give you a clearer impression. Yeah, and hopefully this whole process has been clear enough that you'll be able to repeat it yourselves. I'd love to hear the results that you have off the back of this, and if you have any big wins, then please let me know. Also, any questions, then also please post them in the comments below. Check out my website, check out my Patreon as always, and subscribe. And big up, see you next time. Peace!